Hello, and welcome to the Schneider Electric Data Center Science Series. Our team's mission is to provide industry-leading research on emerging trends and technologies, as well as best practices on how to plan, design, build, and operate data centers. We are pleased to present our founder and Senior Vice President of Innovation, Neil Rasmussen, who with decades of engineering experience and thought leadership holds 25 patents related to high-efficiency data center solutions. So here's Neil talking to you about containerized modular data centers.
We hear a lot today about containerized data centers. With this approach, pre-manufactured data center modules are shipped to a site and rapidly deployed, and can even be located outdoors. There's really no question that modular containerized data centers are going to be an important way to build data centers in the future, and maybe even the dominant way. But it's important to put a caveat on that to explain what we mean by containerized data centers. When we talk about containerized data centers, there's really three elements that must be considered: the IT space itself, the power facility equipment, and the cooling systems. And while it's possible to combine all of those into containerized units and ship them around, what we're more likely to see is data centers where those three functions are partitioned among modules. And in fact, probably most of the IT rooms will not be located in containers in parking lots, but will remain in buildings on floors as we traditionally see them today. However, we do believe that there's a very strong indication we should have power and cooling subsystems located in containers or on skids as part of future data centers. While the industry is still in the early phases of deploying power and cooling facility systems based on containers or skids, we've already learned enough to know and be sure about what kind of benefits we can expect. Our analysis shows a 30% reduction in total cost of ownership, a 13% reduction in first installed costs, and a 60% reduction in time to deploy, all of which are substantial benefits that our customers are looking for. One of the most important contributors is the use of factory-based labor to assemble these subsystems rather than doing it in the field. As we all understand, the costs of labor in the field and the logistics associated with that are going to be much more expensive than doing it in a factory. Another savings we'll see is a lot of the issues with site preparation, because when we're simply locating a few modules, there's a lot less site preparation, plumbing, wiring required to prepare the site for the modules. Another important savings in cost is actually the cost associated with the one-time engineering and the programming of the various subsystems, whether it's building automation systems or controls and so on, that come along with it, normally come along with a unique data center. And finally, one of the most interesting areas that really drives major cost savings for many customers is the reduction in costs associated with right-sizing the system to the application. The use of the modules allows us to deploy the facility infrastructure as needed and where needed to better fit the life cycle requirements of the data center. Customers can expect significant savings in the time to deploy when using these types of facility modules. For example, although we normally understand that the cycle time associated with installation will be improved, and that's a large amount of time, we also get substantial savings associated with the engineering and pre-engineering that's normally required in a data center planning process. Also, we eliminate time associated with the testing cycle. Not all of the time, but a lot of the time is eliminated. And finally, what we can expect to see as the market matures is that many of these modules will become available essentially off the shelf, which will dramatically drive down the lead time and improve the availability of these types of systems. Most people, when they consider the possibility of facility modules, naturally assume there will be savings in time and savings in cost. But one thing people don't appreciate that we believe is very important are the possible reliability improvements. Specifically, we know that many of the kinds of failures that we experience or problems we experience in actual data centers are not caused by the devices that are used, but they were caused during a mistake made during the installation or the interconnection of those devices. And by moving a lot of those interconnections and that field labor away from the field and into a more controlled factory environment where we can inspect and test those steps, we have a really big advantage in improving the overall system reliability. Another thing that we must consider when we look at reliability contributions in real data centers is that a lot of them are surprises. They're not defective equipment, they're not defective installation, but they were caused during the design and are often traceable to the uniqueness of that design. The design is unique, and when you design a unique design, you get unique problems to go along with it. And by making these designs standardized, we eliminate that uniqueness and drive out the variation that contributes to a lot of the problems and downtime we see in data centers. When considering who are the most appropriate customers for this containerized or skid-based approach to data centers, it's important to separate out the difference between the IT space on the one hand and the power and cooling infrastructure on the other hand. Most customers will benefit from skid or container-based power and cooling infrastructures. And so we really think that that is going to be a major trend, and only a few customers with unique physical considerations in the design of their building will not be able to use those approaches. However, on the IT side, it's quite a bit different, and we do believe that most IT deployments will remain in IT rooms, and the market for containerized IT space will be more of a niche market focused on deployments where servers are deployed thousands at a time in areas where it's difficult to put them in a building. The approach we've been discussing here is so radically different from the conventional method of designing data centers that most people assume it can only be applied to new data centers. However, we've identified a very important application for these systems in allowing customers to add capacity to existing data centers, especially data centers that have run out of power and cooling capacity but would like to get another 20 or 25% to capacity in order to extend their life. And these facility modules are a great way to add incremental capacity to those kinds of data centers.
So, given what Neil just said, it should be clear that these modular, containerized power and cooling plants have a strong future. Lower costs, faster delivery and installation timelines, increased reliability, as well as their wide applicability all strongly suggest these types of solutions should be given serious consideration for your next project. If you want to fully understand how the specific savings and benefits Neil mentioned were calculated, check out White Paper 163, Containerized Power and Cooling Modules for Data Centers, and its companion White Paper 164, TCO Analysis of a Traditional Data Center versus a Scalable Containerized Data Center. Both of these can be downloaded for free at whitepapers.apc.com.